Question 8a states, given that 9 sine squared theta plus sine 2 theta equals 8, show that 8 cot squared theta minus 2 cot theta minus 1 equals 0. The first thing to notice is that the final answer is only in terms of theta and not 2 theta. We can convert the sine 2 theta into sine theta and cos theta using the double angle formula. Sine 2 theta is 2 sine theta cos theta. To write our expression in terms of cot theta, we need to remember cot theta is 1 over tan theta, or cos theta over sine theta. So to start writing things in terms of cot theta, we can divide our equation by sine squared theta. If we simplify down, we now have cos theta over sine theta, which we can replace with a cot theta. Now we have to remember cosec theta is 1 over sine theta. So we can replace 8 over sine squared theta with 8 cosec squared theta. To replace the cosec squared theta with cot squared theta, we need to remember the identity 1 plus cot squared theta equals cosec squared theta. If we multiply this out, we can rearrange to get the final answer. Question 8b then asks, hence solve 9 sine squared theta plus sine 2 theta equals 8 in the interval theta is greater than 0 but less than 2 pi, giving our answers to 2 decimal places. First, we remember we've already written this into the form 8 cot squared theta minus 2 cot theta minus 1 equals 0. This equation is really a quadratic in disguise, which we can factorize to the following. The first factor tells us cot theta would equal minus a quarter. The second factor tells us cot theta would equal a half. Flipping these equations up, we get tan theta equals minus over 4 and tan theta equals 2. Now we can use the inverse tan function to get the first solutions from the tan graph. Next, we remember the tan graph repeats every pi radians, so we can add and subtract pi as needed to find the other required solutions. The question asks for solutions between 0 and 2 pi, so we could ignore the first solution we obtained for tan theta equals minus 4. Question 8c then asks us, solve 9 sine squared of 2x minus pi over 4 plus sine of 4x minus pi over 2 equals 8 in the interval of x is greater than 0 but less than pi over 2. Give your answers to 1 decimal place. We can compare this to the equation we just solved. If we compare the arguments of the sine functions, we can see the equations are the exact same, except theta has now become 2x minus pi on 4. This means our old solutions for theta are now the solutions for 2x minus pi over 4. If we now solve for x, we retrieve the following solutions. The question asked for solutions between 0 and pi over 2, so we can discard the last 2 solutions. Rounding to 1 decimal place leaves us with the final solutions of x equals 0.9 and 1.3 radians.